Good evening to the first students who are on. We're giving the others a few seconds more to join. Well, maybe a few minutes more. But, as you imagine, we may just go onto the board and practice a few stuff until they get here. So they will get here in the middle of everything. Of course, we are taking a look at our basic factorization. And as you imagine, just like anything else in mathematics, whatever we have done before will play a very important role. So, as much as directed numbers, indices, multiplication, division of algebraic expression will play a great role in factorization, then also you will find that the basic factorization will come into play when we take another step. And we're going to take another step immediately, because right after this, we will be going into factorization by grouping. And of course, factorization by grouping takes into account your basic factorization, and we expand on that a little. Right? While not being astonishing, the consequences are going to be very rewarding. Okay? So, we're on our way, and we are going to factorize these, and that will make for very interesting encounters this evening. So, just take a good look at the problems that we have right there. We're going to make light work of them in a few seconds. What do we do next? All right. What do we have here? Surely the problems that we are going to solve. But what I will do, I will take tutorial 1. Yes, that's tutorial 1. And I'll put 2. One for me and one for you. That sounds nice. I just saw my black marker. Alright, so I don't see one for myself. Yes, I do. So we'll have 4x squared minus 8x. And we will have 3x squared minus 21x. Oh, this is analogy. 3x squared minus 21x. These two are two analogous to each other. Right. Students, the class has not yet begun. We're just dabbling a bit for the students who joined already. So what is the common factor? What is the highest common factor of 4x squared minus 8x? Of course, we have to take a look at the highest common factor of 4 and 8, which is 4. And also the highest common factor of x squared and x, which is x. Then we divide each one by the highest common factor. So in this case, the 4 will cancel the 4, and x into x squared is x, minus 4 into 8, that is 2, and the x will cancel this x, and that is what we have. Now, you'll have a few seconds to take a look at this one and see what you make of it. Let's go. I'm sure that you'll have been finished with that one a long time ago. All right. So, anybody? Right, so anybody would have completed this one as yet? Come on. Yes, so we have what is common? What is the highest common factor of 3 and 21? That is 7. And students, we may solve this by direct analogy, because we can see the x squared with the x squared, the x with the x, and of course we know the common factor. So we'll have 7x for the common factor, and then what will we do? Same way, the 3 will cancel, and x into x squared is x. It is analogous to the next one. 7 into 21 is 3 times. Yes, there's a direct analogy between these two problems. So you may solve the second one by analogy. Let me see if I can put two, hopefully, I was supposed to be looking in tutorial 1. This one is horrible, but we'll have a nice time with it. 12p cubed q where did I see that? 12p cubed plus 8p squared q cubed plus 8p squared q cubed. And then I'm going to put another one for me and one for you. I can't imagine that I passed so many and none of them is basic factorization. Okay, the other one is nicer for you, more delicious. X squared minus xy. So let me take a look at mine first. So what do we have? What's common in 12 and 8? 4. P cubed and p squared. What's common? P squared. Q and q cubed, q. So what do we say? 4 into 12 is 3. P squared into p cubed, that's a p, and the q's will cancel. Then we go to the next term. 4 into 8, that's 2. P squared will cancel with p squared, and q into q cubed is q squared. Now, take a go at this one. Anybody finish yet? I'm sure that you're finished. I'm 100% sure. As my students would say yes. Say yes. Come on. Without much ado, we have x squared minus xy. We take the common factor as x. And then we have what? X into x squared is x. Right here, the x will cancel the x and the y will be left. And that's your beautiful problem. I'm going to put 2 more before class begins so that we can have a jolly time again. More fun. If I can find any, sure I can. That one is too. These examiners, they don't use their imagination, you know. They try to give you a problem that look close to the other one. Let me just put this one up there. 15x squared y. 15x squared y minus r plus minus 20xy squared minus 20xy squared. And any other? Yes. This one. Alright. 2y squared minus 3y. That's a disaster. It's too simple for me. Okay. So let's go. What's common in 15 and 20? So we say 5. What's common in x squared and x? So I say x. And what's common in y and y squared? I say y. Then 5 into 15 is 3. And x into x squared is x. The single y will cancel. We go to the next term. 5 into 20 is 5. 5 into 20 is 4. X will cancel with x, and then y into y squared is y, and that's your answer. Give you a second to do that one. Everyone gets it right. Of course, what do we say? The only thing that is common here is y. Nothing to cancel the 2 goes back. Y into y squared is y. Nothing to cancel the 3 goes back. And the y's will cancel, and that's your answer. Alright, so we were doing a little warming up, jumping jacks in the meantime. Now it's time for us to begin legitimately. And of course, we have a good number. We have number fluctuating, numbers going up and down already. I hope that is not going to be too much different from the others. And of course, what do I have to say about the others? The others were very entertaining, very enjoyable, very informative, very conversational. And I like that. Right, so we will continue from where we left off. And of course, what do I have to say? If you do not know directed numbers, you're going to have difficulties. And you will see in a minute that yes, you're going to have difficulties if you don't master your directed numbers as you move along. And of course, factorization is per division. Therefore, you'll have to be able to divide algebraic expressions. And you had a wonderful time. When it was close to the end of the class, and I said to the students, we have 40 problems to solve. Right? 40 problems to solve. The students say, 40? The students solved those problems in a very short time, giving me all of the answers and ensuring that all of my answers are correct. And when I had any error, the students were quick to point it out. Right. And I was quick to make the necessary adjustment in what? The interest of everyone, none excluding. And of course, that for me is very interesting. Now, we are with factorization, and we will have those, these are trinomials, this is a binomial, but we are looking at our basic factorization. Basic factorization, that's what we are focusing on. Nice. Now, our basic factorization, first rule is find the highest common factor. Second rule, divide each of the terms by the highest common factor. When something is common in mathematics, it is not just popular, like in real life, it is more than popular. If it is common in mathematics, it means it is present in all. Right? It pertains to all. And that's what we mean when we say that it is common. So the common factor, in that case, we're going to look for the highest one, the largest or the maximum expression that can be divided into all of those. Right, so let us do that immediately. I'm trying to use a blue marker. Yes, I'm trying to use a blue marker. There it is. So let's go. Now, what's common? Students, you have to consider that these mathematical expressions are also, as much as they are logically endowed, they are visually comprehended, and they should be a visual approach to the problem. Because if you're trying to find the highest common factor, you realize that P and Q alone are present in all. So because A is not in this first term, nor this term, and because B is not in this term or this term, then we know that B cannot be a part of the highest common factor. So we have to go with the P's and the Q's. So we have P squared, PP. So we are going to use P in our highest common factor. Then what do we say? Q squared, Q squared, I hope it's Q squared for the in the second case. Yes, it is. P squared Q squared minus APQ plus BPQ squared. Yes. So what do we say? Q. Now students, you can divide as much as you can multiply. So at all times, you are balancing things off. So you don't just go straight ahead and you have no way of discovering if you are making a mistake or not. You have always of discovering whether you're making a mistake or not. All right, so let's go. And I will take a look at that. So, I'm going to take this approach. I'm going to take only, I'm supposed to be dividing because we have taken the highest common factor. I've taken the highest common factor and we need to take this into this and put the answer there. But I'm going to take purely, in this case, a multiplication approach. Because as I said, you can what? Multiply. You can divide as much as you can divide. I hope that the students are seeing the screen. Is the screen okay and everyone is seeing the screen? Or do we have a clear screen? Anybody can tell me if we have a clear screen? Because my monitor is clear. Is the screen clear? No one to say whether yes, the screen is clear or no? Okay, thanks. Okay, yes. Oh, that's nice. Beautiful. All right, so let's continue. Now, as I said before, when we are factorizing, we need to take the highest common factor and divide each of the terms by the highest common factor. But I say now that I'm going to take a multiplication approach rather than a division approach to the problem. So let me take a go. Let's go, students. Help me with this one. Now, I'm going to say, whatever I have with this, I should get this. So whatever I put here, when I multiply this with this, I should get this. So if I have a p squared here, we have to multiply by a p, because p times p is p squared. And of course, if we want a q squared, q times q is q squared. See, we can take purely a division approach to it. Now a multiplication approach. Look at this. We want a pq, but we have the pq here already. So all we need to do is put an a. We need all of this here. There's no b, so we have to put a b. We have the p already, so we don't have to put another p here. And in order to get a q squared, we have to put a q here. So we are saying that we are going purely from the perspective of the fact that we can place what we need to place here because we know that it should multiply to give that. And of course, that is purely what division is all about. Division is what? The reverse or the inverse or the reciprocal. So it's the inverse of multiplication. That's what division is. So while we need to divide, we don't really have to divide. We do the reverse of multiplication. So we could multiply still and get the answer, but it depends on the direction from which we multiply. What do we do with this one? We look for the highest common factor. We have 9, 6, and 3. Obviously 3 will work. What about the m's? M cubed, m squared, and m. N squared, n to the power of 5. N. Division this time. Let's go. 3 into 9 is 3. M into m cubed. We have 3 of them up here and 1 down there. When they cancel, 2 will be left. So it's going to be m squared. So m into m cubed is m squared. The n's will cancel. And what do we have next? Students, do not forget that you're going to have your homework. I'm doing 3 of the problems from your homework. 3 into 6, that's 2. M into m squared, that's m. N into n squared, that's n. Plus what? The 3 will cancel. See? 3 will cancel with 3. M will cancel with m. And n into n to the power of 5. 5 occurrences multiplying up here and 1 occurrence multiplying there. 1 will cancel here with 1 of those up there, and we'll have n to the power of 4, like that. So 5 in the numerator and 1 in the denominator. When they cancel, 4 will be left in the numerator. You can think about it like that. Nice. Now, students, these are problems that we were doing before class started. You know, doing a little bit of jumping jacks. And of course, we are going to do these problems when we are doing our tutorials later on. All right. The next thing will go away, of course, that because I want to start over there. Students, we don't have to spend the entire time on this because you have both the problems and the solutions. So let's go. All right, so let's continue. Students, that's your basic factorization, and we are going to go into factorization by grouping. Factorization by grouping. And of course, let me tell you where we are at. But students, do not code. Pay attention and make sure that you learn, because after a few examples, you're going to have to do some on your own. You may as well learn them. Factorization by grouping, and of course, that is on page 16. Yes, factorization by grouping, and that's on page 16. It's, what, 3 examples we have? But students, you must pay attention, because although we have 3 examples, we're going to have 3 stuffs to explain. Okay, the person who said that you do not understand, ask to be ask to get into the chat, and I will accept it, and then you can tell me what you don't understand, and then I can explain it. So make your request and I'll let you in. Let's go. Okay, understand that now. Okay, the person who does not understand, is this your first class? Did you come at the beginning? When did you begin? Let's go. Okay, is my video still frozen for everyone, or is just for a few? Okay, there's another person saying it's frozen. No, it's the same one. I'm addressing the person who said that you do not understand. Why would you say that you don't understand if you don't want to understand? I'm waiting for you to say something. Okay, it's good now. Oh, it's in and out, some students are saying. Okay, so at the moment, is anyone hearing what I'm saying? Is it clear? Is the video also showing okay? Is the video okay? You know what I will have to do? I will have to take up the phone, go on TikTok, and look at it myself instead of asking you all. Okay. Well, so far, I'm not hearing the audio going back. Are you hearing me? So, yes. Are you hearing me? I should get. Okay, no problem. Well, so if I need to know, I'll just look right there. If it, if it doesn't get failed. All right. All right, so we will go straight ahead. Yes, we'll go straight ahead. Yeah, there's somewhat of a delay, as a matter of fact. And I don't think that I'm seeing any frozen repercussions at the moment. And I have to put it in a position where the sound is not 100% to me, because it will be too much for you. No. I am monitoring it, and I'm seeing a beautiful screen, clear as crystal, because I have the monitor right there. So for those students who are seeing a black screen only, then it is your device or your internet connection that you're having difficulty with, because I am also monitoring it on a device down here. All right, so let's get going. Your first factorization, students. I will not just go straight ahead and just and factorize. What I will also do, I hope that I can find my old book, my old manual, yes, because I think the problems are the same. All right, so I prefer to work with this one. Let's go. So I'm going to put it right here. 15x squared y plus 9x y plus 10x plus 6. I could put it as plus 6 closer. I'm going to make provisions for the abnormalities. Plus 10x plus 6. All right, so let's go. Now we are going to factorize by grouping. Yes, we are going to be factorizing by grouping. What it means is that we are going to factorize the first two, then factorize the second pair. After that, then we do an overall factorization of the resulting expression. So let's go. The first thing that we will do, as a matter of fact, the first thing that we will do is factorize these two. So for these two, what will we do? We'll take the highest common factor of 15x squared y plus 9xy. Any suggestion? Any suggestion? All right, so the largest number that will divide into 15 and 9 without a remainder, that largest number is 3. So we are going to be, yes. I'm getting sound, students. And I'm monitoring it from another device. And I'm getting sound clearly. And I'm seeing also. So it's not TikTok and it's not my connection. All right. So x squared and x, what's common? X. Y and y, what's common? Y. So let's go. 3 into 15 is 5. X into x squared is x. And the y's will cancel, being the same. Then we have what? 3 into 9, that is 3. The x, y will cancel the xy, as you can see. Xy will cancel xy, and that's where it ends. Thank you very much. For the second pair, we need to begin the second pair with the same sign that is here, which is a plus sign, so plus. And after we say plus, what's common in 10x and 6? What is the highest common factor of 10x and 6? The highest common factor of 10x and 6, I'm going to, since you're not supplying an answer, I'm going to supply 1. And as soon as I supply 1, you're going to tell me that I am wrong. But you'd have to tell me where I go wrong. No answer as yet? What's the highest common factor for 10x and 6? Just the 2. Just the 2. The x is not present in 6. So that's not common. Then what do we say? Yes, it's 2. Then what do we say? 2 into 10 is 5. Nothing to cancel the x, it goes back. And then 2 into 6, that's 3. And what the teachers will say is that you invariably place the 5 plus 5x plus 3 there. And in the other brackets, we put the 3xy plus 2 unapologetically. Now, how did we arrive at that? Well, teachers take it for granted that you can just put the 5x plus 3, which is common, in one bracket, and in the next pair of brackets, you enclose 3xy plus 2. And if you do that all of the time, you will be right. And it is going to be of no one's concern why you do that. Okay. Yes. So what do you do now, students? You see, if there's too much of a delay, then you go ahead of me. You answer the question ahead of me. And then you'll get it right. Now, students, pay attention to what I'm doing. Now, some teachers instruct the students to do this. So the teachers will say that you should do this. When you're factorizing by grouping, you should do this and group them like that to show that you are taking this 2 and this 2. And you know I am disgusted by that. Because why would you have to put brackets there to show that you are taking them 2 by 2? As if everyone in a mathematics class cannot count to 2. And if you see the first 2 terms, you will not be able to identify. You may go over and put this one inside here and don't know that it is 3 terms. Or you just take 1 and it's just 1. Why do you need to do that? Okay then, let's do a little discussion on it. If you do this in an examination and the examiners see this, is this correct? And if it is correct, say yes, why it's correct. And if it is no, say why it is not correct. Is that correct? Is that correct to put the brackets there? Students, I am monitoring the live from a device, and believe me, it is not only the chat is delayed. The entire thing is delayed. Yes, and it is not just delayed by 15 seconds. It's delayed quite a bit. Yes, yes, it is delayed, significantly delayed this evening. Yes, and it's not because of the system. Well, it's coming from TikTok's end. It is saying that the video is delayed, that's all. And I've asked questions and there is no attempt at any of the answers. Let's go, students. Although it is delayed, as soon as you hear the question, you may supply an answer. All right, sir. All right, students. Maybe it's the rain. What I'll do, I'll attempt. So maybe by the time you see the message, I'll be out. But I'm going to attempt Yes, I'm going to attempt to restart the live. Okay. All right, so is it any better now? For me, it's no better. So, okay, some says yes, it's better now. My screen is black. My screen is frozen. The monitor, the device that I'm using, the screen is frozen. Oh, well, my screen is still. I think that my screen is just making use of something that was there before. So we're having some serious difficulties this afternoon, evening. Okay. Yes, we are having some serious difficulties. So somebody is attempting the call. Good evening. Yes. Yes, I'm upstairs. Okay. Okay. How is it now? Right, my screen is black. Okay. All right, so the screen, some saying it is good, some say the screen. Well, I think that I'm seeing a delay, but surely that's a black screen. Okay, well, go straight ahead with the question. When you're given the quadratic expression and you're required to factorize this by grouping, the teacher sometimes instructs the students to introduce brackets that were not there before. Now, let me do it over in a few seconds. And then what I want though is for you to tell me, this is the original expression. That's the original expression. Now, I'm going to do this first. If the teacher tells you to put them in brackets and you do this, is that correct or incorrect? And why? So tell me if it is incorrect and tell me why. Tell me if it's correct and tell me why.
Okay, that's the same
Yes.
your father spoke here.
Oh.
The order we came.
So yes, yes.
No,
Oh, yes.
Okay. So this is the third.
So what we normally do, we usually take this, this, and tutorial 1, and tutorial 1. This is a book factory at the moment. See?
Yeah, man.
We have two of these. So this book is so you say it's 12 now?
Yes.
Okay. So there's another book that you have to have.
Are you only giving it 13 5 then and I'll hold you the pen?
Okay. Alright, so this is let me see. You're gonna do the 13 5?
You have change?
Do 30.
Alright, I'll do 13. So I'll look in.
Maybe you'd have to bring the books and you're coming back for me to see the books that you have.
I'll read that. Alright, no
Yes.
problem.
Because this is not a typical exchange. Alright, so these are the books. Let me make sure. So it's 13. Let me see how many more of these can put with all of them. Generally, we put 7, 7.
Yeah.
Yeah, so we don't have any difficulty, but this time it's a larger number. So we might have. This one is clean. And then this one is the finish book. Yeah, that's.
Ready?
Thank you. You're welcome. Okay.
So, for tomorrow, I will be 11.
Okay, if you can send me a WhatsApp message, then that will be fine. Although it's not necessary because all you have to do is type Richard James Math Resources. You can see because all of the books have Richard James Mathematics Resources on it.
Okay.
So if you just type Richard James Math Resources on TikTok for the search use and say Richard James Math Resources Live, you should get in.
Really?
Yeah, because
Okay.
my WhatsApp message I send you the link for the TikTok.
Alright, no problem.
Thank you. You're welcome. Okay, sorry about that, students. Let me see why. Screen still black. I asked a question, no one attempted to answer it. Come on. Okay. Right. I just asked about the introduction of the brackets. If we introduce them like we have them right there, would that be correct? One say correct. Anybody for incorrect? Because it's not correct. It could not be correct because when we have the brackets like these and they are not separated by anything, then the operation that we assume is multiplication. So when we have it like this, here is being multiplied by whatever we have there, which is quite different from the intention of the expression, the original expression. There was no indication of any desire to multiply. So the expression was just a flat expression, addition of algebraic terms, like that. But when we introduce the brackets, as you saw that we introduced them just now, what do you know? That because of how they were introduced, then it is indicating that the two sides of the expressions are being multiplied by each other. So let me do that again. So you can see, there's no, what I did now, there is no operation separating the two brackets. There's nothing separating the brackets. And that means that they are being multiplied. So that could not possibly be correct. Is that okay? Now, a way that we can just do it, because all we need to do is change this one and put it here, and that will be correct. Now that will be, it's being separated by the addition sign, meaning that whatever we have here is being added to what we have here. Okay. But as you can tell, I will continue without introducing the brackets. So we're going to take those out. And we'll continue with other exercises, and we'll see the significance of the brackets inside there. Now, how do we arrive at this final expression? We factorize these two, and this is the result. When we go to the second pair, we use the sign that begins the second pair, and we factorize again. Finally, 5x plus 3, we have in both brackets. That goes there, and the remainder will go in the next bracket. So that not the remainder, the other terms will go in the next bracket. So we'll have a 3xy plus 2, and that will go inside of the next pair of brackets. That's excellent. Right, so here goes another one. And of course, I'm measuring the light. Right there. Oh, no, I will not go to another one yet. Now, students, you are told that, of course, you can put anyone in any of the brackets. That's fine, because it's multiplication, so the order does not matter. But for me, I will always put the common factor first. So in every single case, you take the common factor and you put it first. Then in the final case, I'm going to take the common factor and put it first. And then, of course, what will go inside of the next pair of brackets? 3xy plus 2 will go there. But how does that work? Because you're told that factorization has a particular order. And we will go straight ahead and look at that order. Let's take a look. 3xy 5x plus 3 plus 2 5x plus 3. So what do we say? We will have a 5x plus 3 right there. What do we do? Let us take the common factor first. The common factor is the 5x plus 3. So that's your common factor, 5x plus 3. That's your common factor. And then you have 3xy 5x plus 3 plus 2 5x plus 3. And remember that when you're factorizing, you take the highest common factor as we have it right there, and then you're going to divide each of the terms by the highest common factor. So you're going to divide this term by the highest common factor, which is 5x plus 3, and you're going to divide this one also by 5x plus 3. So notice that what we have here is the same expression that we have here. We have taken out the highest common terms by the highest common factor, as you see right there. So what will happen? Students, I'm just showing you that we just do not do this. we have a reason for doing it. It is right in line with the concepts of factorization. Of course, you're going to take the highest common factor and you're going to divide each of the terms by the highest common factor. And the highest common factor of this wide expression is 5x plus 3, so that's the common factor right there. Each of these by the highest common factor, and we have it right there. So when we are through, these two will cancel. Also, this will cancel with this. And what we'll have at the beginning is there's 5x plus 3 still. And 3xy will be left. And of course, the plus 2. So that is why the 3xy plus 2 will go inside of the other pair of brackets. Right? Right. Now, deep breath, and then I'll put the next one on the board. Students, we're not going to spend the entire evening because you have all of these problems, you have their solutions. So you don't have to spend the better part of the night writing anything. So let's go again with another one, and I'm going to need your assistance with this one, especially in the placement of the brackets that were not supposed to be there, but were introduced. But how would we say that they were introduced? They were introduced mysteriously or mischievously, if there is such a word, or in a mischievous manner. You cannot say that, I cannot say that. Alright, so let's go. 12AB. So we have AB. I'm looking at the light. It's almost inside here, so I'm going to drop it down. So I'm going to put it a little bit down. 12AB plus 8A plus 8A minus 9 minus 9B squared minus 9B squared minus again 6B. So here's my question to you, students. If I put my brackets here and some say parentheses, if I put those there, would that be correct? If I put the parentheses like that, would that be correct? Do we have such a great delay on this occasion? Let's go, let's go. Is this okay? No, it's not okay. No, we see another one coming up. No, it's not okay. It's not okay because the intention is multiplication there. All right. So we see that there's at least one case in which the introduction of the brackets will be What about if we do this? Would that be correct? If we do that, would that be correct? Well, obviously the other students are seeing. So maybe all right, so maybe So is it better now, students? I'm sure that it is better. No, right. Okay, you said that. No. Are you still seeing the lag? Yes, I see the freezing. So I'm just hoping that is my device. Right. I see that it's going a little bit and it's frozen a bit. But I think it is a little bit smoother now. Do you think that it's smoother? Okay, right. I think that this time it's a little bit better. It's going better now? Yes. Okay, great. Oh, yes, I'm seeing the green and all of the rest of it. The same thing that you're seeing. And the freezing and all of that. All right, so well, I think that this one is not too bad now. I think it's not too bad. All right, so let us give it a few more minutes of this and then see if there's any other adjustment that needs to be made. All right, so here's the question continues. Is that okay now? So the way that the brackets are placed now, does that make it correct? One said yes. One's okay, so oh, yes, sir. Okay. And one said there's no sound. Okay. Okay. All right, so let us continue. Now, students, by placing the brackets here, we are still wrong because of this negative sign here.